Okay, welcome to week 5 of 8. Today is going to be 11.2, Introduction to Polynomials, Classifying, Adding, and Subtracting Like Terms. Okay, so a bunch of vocab today, and then some combining like terms, writing in standard form, and adding and subtracting. Okay, so as we do this, we'll move forward and all that. Okay, so this week, and then for weeks numbers 6, 7, and 8, you only have notes, a worksheet, and Delta Math. Go formative at this point is no longer for us. So weeks 5, 6, 7, and 8, basically the last 4, Delta Math only, along with these notes and the worksheets that I send. So there is no, you know what the expectation is at this point. So if you want to raise your grade, if you want your grade raised, 100% completion, 100% effort in what we're doing, and then you have to score pretty well on the homework checks, okay? Just above average. So here we go, 11.2. What is a monomial? And you're going to see that little thing mono kind of highlighted there for you because mono means one, right? So a monomial is a single term, and it is made up of numbers and or variables. Now remember, I said and or there, right? And or. So basically, some examples of a monomial. Simply, the letter, and let's change color here. The letter X would be a monomial. 7X would be a monomial. Just 7 would be a monomial. 7XY would be a monomial. And, 7ABC. All of those are examples of monomials. The bottom line is it is just a single term altogether. There is no addition or subtraction, which means that's how you get more than one term, is when you have addition or subtraction involved, okay? How to find the degree of a monomial. So how do we find the degree of a monomial only, okay? This is going to trick some of you up as we get in more into the definitions. But for the monomial, it's the highest exponential value when we add the exponents together. So it's the highest exponential value when we add the exponents together. Okay? Highest exponential value when we add the exponents together. All right, so let's show an example of this, okay? So if I had 7ABC, well, the powers of A, B, and C here are just 1. They have an exponential value of 1 because there's nothing up above it. So my highest power, the degree of this monomial, the degree of it is going to be 3. Now, I'll do another one just right below it so you can see. If I had 9x squared, y to the third, and z to the fourth, my degree here is going to be 2 plus 3 plus 4. So my degree for this monomial would equal 9. Okay? So how to find the degree of monomial? You add up the powers of that monomial, and that is its degree. So what is a monomial? What is a polynomial? That's the next one. What is a polynomial? And a polynomial is terms made up of numbers and or variables from one term to an infinite number of terms. Okay, so technically a monomial is a type of polynomial. Okay, so a monomial is a polynomial. Okay, so polynomial is the big kind of header, just like when we did four-sided shapes. Quadrilaterals is the top, and then we did parallelograms, rhombus, trapezoids, squares, rectangles, all that underneath a quadrilateral. This is the same idea with a polynomial. So some examples of a polynomial are, and I'm going to do them down here just so we can keep space down here. So I'm writing down here. So simply what we saw begin, and x is a polynomial. Technically it's a monomial, but it is a type of polynomial. 3x plus 1 is called a binomial, which is a type of polynomial. And then I also have like 5x squared plus 2x plus 1. That would be an example of a trinomial, which is a type of polynomial. Okay, so all of the encompassing of it. So like when I say a rectangle is a quadrilateral, correct. A rectangle is a quadrilateral because it has 4 sides, right? But it is also a specific type of quadrilateral called a rectangle. Well, in this case, all of these are examples of polynomials, but they also have a very strict name as well. Okay, so polynomial, basically anything from one term to an infinite number of terms. Okay, now I'm going to erase some stuff here. So if you need to get this, make sure that you always just rewind and pause, do any of that kind of stuff, right? Now, how to define the degree of a polynomial? It is the highest degree from the terms in a polynomial. Now, this is different than finding the degree of a monomial. Monomial, there is only one term, so you have to add them all up. In this case, each term has a degree, and that's how we do this. So it is the highest degree from the terms in the polynomial. Okay, so if I had this polynomial, if I had 3x to the fourth plus 2x to the third minus 6x squared plus 8x plus 7, the highest degree here is going to be the degree of this polynomial is going to be the highest degree present. In this case, that means the biggest power, right? So when I look at that, if I got 3x to the fourth plus 2x to the third minus 6x squared plus 8x plus 7, this 4 right here, this power of 4, and I'll highlight it, this power of 4 is going to be my highest degree. So the degree of this polynomial is 4, because that is my highest power present. There isn't nothing to add up because each one of these are separated by an addition or subtraction term. Okay, now monomial is only one term, so you add up the powers. Here you're looking for the largest power. Okay, I'm going to erase again to give myself some space. Okay, now it says, what is standard form of a polynomial? The standard form of a polynomial is highest slash biggest power to smallest power with a constant last. Okay, with the constant last. And in that example I just did that you saw, so when you saw this 3x to the fourth plus 2x to the third minus 6x squared plus 8x plus 7, the one I just did, well, that is in standard form. And I know it's in standard form because it goes from the highest power to the lowest power. It goes from 3x to the fourth, power of 4, then the power of 3, then the power of 2, the power of 1, which is not written, right? 8x, nothing written above it, so it's a power of 1. And then the 7 is a constant. It's just a number, and that goes last. That is standard form. Okay, highest power to lowest, constant goes last. Highest power to lowest or smallest, constant goes last. All right. And then last but not least, what is the leading coefficient of polynomial? It is the number attached to the variable with the highest degree. Okay, now I'm going to erase this so I can write right next to it. Okay, so if I gave you 9x plus 5x squared minus 6, well, one, that's not in standard form, right? It's not in standard form. So if I was to rewrite this in standard form, it would be 5x squared plus 9x minus c. Now, or minus 6, not c, minus 6. Now, my leading coefficient is the number attached to the variable with the highest power. And in this case, that is this 5 right here. It's not the x squared. The x squared tells me that is the highest power. The 5 itself, 5 is the leading coefficient. Remember, coefficient is the number attached to a variable. In this case, the leading coefficient is the number attached to the variable with the highest power. So it's simply the 5. If you write me 5x squared, it is wrong because I'm not looking for the entire term. I'm looking for the leading coefficient. Coefficient means number attached to a variable. All right, so let's get some more of this. So classifying a polynomial by degree. Well, 0. Well, if we know this, because we just did this the other day, 3 to the 0 is what? 1, right? A 1, right? So in case of that, that is basically a constant, right? Degree of 0. Now, in terms of things that we're doing by, right? In terms of things we're doing by, I also know that, and I want you to understand that any number is going to be treated as if it has a power of 0 because it doesn't have a variable. So any number or constant, okay? So in terms of what we're doing, basically a constant always goes last, right? So I don't want you to thinking that, okay, if it's 0, then it always has to be 1. That is correct. But remember, in terms of putting things in standard form, our number, whatever number it is, 1, 2, 3, 4, 5, whatever the constant is, it always goes last. If it has a power of 1, okay, this is going to be called linear. And you should know this already. An example of that is just x by itself, linear, right? No power above written above it, which means it has a power of 1. That is a linear term. Okay, it has a power of 1, linear. Y equals mx plus b. It's a linear function. Why? Because the x has a power of 1. A power of 2 is called a quadratic. You should know that as well. So this is x squared, quadratic, right? Power 3 is called a cubic. 4 is called a quartic. 5 is called quintic. And 6 and more is just the nth degree. And what I mean by that is whatever that value is, that's what it's referring to. So an example of this would be x to the 12th would be called the 12th degree, okay? So anything at 6 or more, it is called whatever that value is, whatever that number is, that's what degree it is. The only ones that have special names are basically from 1 through 5. Linear, quadratic, cubic, quartic, and quintic. Okay? All right. Classifying a polynomial by term. Okay, one term, we already know this, is called a monomial. 2 terms is called a binomial. Okay, so a monomial, just like 2x. A binomial, 2 terms, 2x plus 4. That's a binomial, 2 terms. 1 term with a plus or minus in between and another term, binomial. 3 of them are called a trinomial. Let's say 4x squared minus 2x minus 4. 3 terms there written in standard form. Highest power to lowest, constant goes last. And that is called a trinomial. Anything 4 or more is simply just referred to as a polynomial. Now remember, all of these are polynomials. The first 3 have a more specific name in addition to being called a polynomial, okay? I.e. monomial, binomial, and trinomial, okay? So 4 numbers. All right, so let's do an example and see if you can get this right, okay? So if I wrote you this example, right here, and I asked you to classify this by degree and by the type or the number of terms, right? So classifying the polynomial by number of terms and by its degree, your answer would be, well, it should be a quintic trinomial, okay? Quintic because it has a power of 5, that's the highest power. Trinomial because there are 3 terms. Now, if I ask you what my leading coefficient would be, you should say 6. And why is my 6 my leading coefficient? Because it is the number attached to the variable with the highest power. All right, so let's do some examples and do some adding and subtracting of this. All right. So now that we have this, let's get into it. Example 1, simplify, then classify the expression. I have 15m to the third plus 6m squared plus 2m to the third. Well, I need to simplify this, and simplify really is referring to combining like terms, right? I want to combine like terms. Remember, simplify, combine like terms. Well, in this case, I have 15m to the third and 2m to the third are like terms. And why are they like terms? Because they both have the same variable with the same power, right? They have the same highest power, power of 3, right? So 15 plus 2 is 17. So I know that when I combine this becomes 17m to the third plus 6m squared. M to the third and m squared are not like terms, so therefore I can't add them together like making this 23m to the fifth. I can't do that, okay? So, and you should know that because we just did properties of exponents, right? So now I have simplified this. I combine like terms. Now it wants me to classify the expression. So in this case, I know that there are 2 terms, so I know it's called a binomial. And then what is its highest power? Well, its highest power is 3, so this is going to be a cubic binomial. And in this case, my leading coefficient is going to be 17. All right, next one. Simplify, then classify the expression. 3x squared plus 5 minus 7x to the third plus 12. Well, when I look at this, there's only a power 3. There's a power 2. And then there's a constant here and a constant there. So I really only have one set of like terms, and that is my constants. So when I look at this, I want to go ahead and write this in standard form, and then I want to combine like terms at the same time. So my highest power is at negative 7x to the third in the yellow highlighter. So I'm going to write that first. So negative 7x to the third. And why do I know it's negative? Well, because it's got a minus sign in front of it, and that minus sign goes with it. It's negative. Then that's going to be 3x squared. Well, there's nothing in front of 3x squared, so that is a positive. So you're going to write a plus. And then I have 5 and 12. And it's plus 5 and plus 12, so therefore they're both positive. So I'm just going to simply add them together, and because of plus 17. Now, when I look at this, how many terms are there? Well, there are 3, so that's called a trinomial. And what is my highest power? Well, once again, it's 3, so it is a cubic. Now, also, hang on there, my leading coefficient here. Well, what's my leading coefficient? My leading coefficient is the number, right, that is attached to the variable with the highest power. In this case, it is a 7, but more importantly, it's a negative 7. So negative 7 is my leading coefficient. The sign in front of it goes with it. If there's nothing in front, then it's positive. But since there's a negative, it goes with it. So my leading coefficient is a negative 7. All right, now, these are going to be a little bit more difficult. So I just want to make sure that you understand this. It says simplify then classify the expression. And I have a binomial, a to the fourth minus 2a in one set of parentheses. And I'm subtracting from that a trinomial inside parentheses of 3a to the fourth minus 3a plus 1. Well, here's the thing with subtraction or subtracting polynomials. And that is the minus sign that's in front of the minus sign here. This minus sign right here, right there, has to get distributed with all 3 terms of this trinomial. That negative has to go, that minus has to go with every term. So what I'm going to do is I'm going to distribute a negative 1. I'm going to distribute a negative 1 with each term. So this is how I do it. I'm going to just go ahead and bring down the a to the fourth minus 2a. Okay? Because there's nothing I can do with it yet. Now, I'm going to distribute that negative 1 with 3a to the fourth. So negative 1 times 3a to the fourth is a negative 3a to the fourth. A negative 1 times negative 3a. Negative 1 distributed with a negative 3a. Well, negative, negative become a positive. So this is a 3a. And then I have a negative 1 times 1. Negative 1 times 1 is simply negative 1. Now, I want to combine like terms. When I'm looking at this, what are my like terms? Well, I know I have an a to the fourth and a negative 3a to the fourth. Those are like terms. I have a 3a and a negative 2a. Those are like terms. And then I have simply just a 1, which is right here. So when I look at this, I want to combine those and put it in standard form. And I'm going to do it all at one time. So a to the fourth minus 3a to the fourth. Well, 1 minus 3 is negative 2. So negative 2a to the fourth. Negative 2a plus 3a is simply a. Negative 2 plus 3 is 1. So just 1a. And then my constant, negative 1, goes last. Standard form, highest power to lowest, constant goes last. Now, when I look at this, what is this going to be called? Well, 4 is quartic, so I know the highest power is 4, so quartic. There are 3 terms, so this is a trinomial. And my leading coefficient here is going to be a -2 because it's attached to the variable with the highest power. All right. Now, adding polynomials are much, much easier because they're straightforward. Because basically all you're going to do is drop the parentheses. Okay, so when you have an addition, just drop the parentheses and go as is. So what I mean by that is I can simply just drop all of them. And now I'm starting looking for combining like terms. So I have a 2x squared and an x squared. I have a negative x and a 3x. And I have a -1. Those are all of my like terms in their individual colors. So when I see this, I want to go highest power to lowest power. My highest power is 2, so I'm going to say 2x squared plus x squared is 3x squared. Negative x plus 3x is a positive 2x, and my constant is last. My leading coefficient is a 3 because it is the number attached to the variable with the highest power. And then how many terms do I have? Well, I have 3, so this is a trinomial. And then the highest power is 2, so it is a quadratic trinomial. Okay, always degree first, number of terms last. So quadratic trinomial, quartic trinomial, cubic binomial, cubic trinomial. Degree first, number of terms after that. All right, we'll do 2 more and you'll be done with this lesson. I have x squared minus 2x minus 3 plus. That tells me what I'm looking for right there, that plus, right? X to the 4th plus 2x plus 1. So I'm going to simply drop the parentheses and look to combine like terms. I have 1x squared. I have a -2x and a 2x. Okay, so those are x's. I have a -3 and a 1. Those are my constants. And I have only 1x to the 4th. Now notice that I use colors to do this. Now you don't have to do that, but I'm doing it so you can see which ones are like terms and I can go from there. Now, I want to put these in standard form when I combine like terms at the same time. So which one is the highest power? What happens to be x to the 4th? So x to the 4th goes first. My next highest power is x squared, so this is going to be plus x squared. And there were only one of each, so I didn't really need to combine them. I just had to put them in their order. Remember, there's nothing in front of x squared, so that is a positive, so it goes in as plus x squared. Now, there are 2 x's, -2x plus 2x. Well, how many is that? Well, 2 minus 2 is 0. So there are no more x's. They wiped themselves out, so those are gone. And now I'm down to my constants, -3 plus 1. So this ends up being a -2. So plus a -2, and I'm just going to simply write it as -2. Okay. Now I could have wrote it as plus -2, and that would have been the same thing. Now, what is its highest power? 4. So this is a quartic trinomial again with a leading coefficient of 1. Okay. The number in front of the variable with the highest power. Well, there is nothing in front of it, which means it is a 1 in front of it, 1x to the 4th. All right, last one for the day. 2x squared plus 3x minus 4 minus, that's key there. So that means I'm going to be distributing a -1 with each and every item. Okay, so bring down the first one. because I don't need to do anything with it. I'm just dropping the parentheses of the first one. And now I need to distribute the negative with all of those terms. So -1 with 2x squared is a -2x squared. A -1 times 5x is a -5x. And -1 times -6 is a +6. Okay, combine like terms. I have a 2x squared out front. I have a -2x squared right there. I have a 3x right here looking for any x's. There's another one. And then I have a -4 right there and a +6 right there. And that takes care of all of my terms. So find the highest power. Well, the highest power is squared, right? It's 2. So combine those. 2x squared minus 2x squared. 0x squared. So I don't even write it. They're gone. They cancel each other out. I don't need to write them. Now my next highest power is this linear term, x. So positive 3x plus 3x minus 5x ends up being a -2x. And then a -4 plus 6 ends up being a +2. So on this one, this is going to be a linear binomial. And my leading coefficient is going to be a -2. It is the value, it is the number that is attached to my variable with the highest power, in this case, -2. All right, I hope you enjoyed this lesson. This is the first of 2 lessons for week number 5. Have a great week.